Good afternoon, everyone. I hope everybody is doing well. Let us continue our chapter. Yesterday, we stopped, I think it was the example of the net worth. It was the last thing that we discussed, like if the duration of the assets was 3 years and duration liability of, let me share the screen with you then. So this is the example. Yesterday we started actually on that, and we were discussing like this example. There was like duration of 3 years and duration of 2 years, and there was 100 million of total liabilities and total assets 120, and where the interest rate were originally like 10%, then it suddenly increased to 12% by 200 basis, and the question was what happens to the bank's net worth, and the net worth is here, how it's calculated in the previous slides. You can see it's how it's being calculated. So the formulation is given here, and what we saw that minus 2.91 million. So the net worth of this bank declines by 2.91 million as a result of 2% increase in the market interest rate. So there is some strategies we can get it actually, the change in interest rates, how it affects the net worth using the duration gap. If there is a positive gap, like difference between duration assets and duration liability, so increase in interest rate, that will reduce the net worth of the bank. A fall in the interest rate, that will increase the net worth. And if we have a negative gap, then we will have the opposite, like increase of interest rate in the market, that will increase the net worth of the bank, and increasing the reduction of the interest rate will reduce the interest rate with a negative gap. Or if it's zero gap, there's no change actually. And the gap we're talking here is this one, like duration gap, okay? And this is the strategy we used actually. So we're gonna go through examples, and there are many examples that will pay attention, then we'll go further actually. And the last slide, there are some limitations that are given for the duration gap, like finding the asset and liabilities of the same duration gap is very difficult actually. And some assets and liabilities may have patterns of cash flow not well defined as well, and customer prepayments may disturb the expected cash flow and duration. And the last one, that no linear relationship between the price and the interest rate is determined actually. So let us go with the book examples, end of the chapter. Now, interest rate risk. This is the interest rate risk, and if we go, we should start with summary. Okay, here's the question. So let us skip the question. Like first, what is the difference book value accounting and the market value accounting, how the interest rate affects, and let us just skip this question. I would like to get the second question. It's a theoretical one, but brief. Let's go with that. So what are the two different general interpretations for the concept of duration, and what is the technical definition of this term, and how does duration differ from the maturity itself? So the duration measures actually the weighted average of life of an asset or liability in economic terms, if you compare to maturity actually. As such, duration has economic meaning as rate sensitive of interest actually changes. In economically, if you would like to speak, what is the sensitivity of rate changes in interest is we call like interest elasticity, how much the interest is elastic of assets value to the changes in interest rate. So duration simply differs from the maturity as a measure of interest rate sensitivity, because duration takes into account time of the arrival and the rate of the reinvestment of the old cash flow during the asset life. So technically, the duration is the weighted average time to maturity using the relative present value of cash flows as weight. So this is how we define the duration and how we make the differentiation with from the maturity. So it's measuring the sensitivity of assets to changes in assets and liability, changes in interest rate. So let us go with example 3, how it works. So we have 2 bonds are available for purchase in financial market. The first bond is a 2-year with a 1,000 bond that pays annual coupon of 10%. The second bond is a 2-year that pays 0 coupon bonds. Okay, so what is the duration of the coupon bonds if the current yield to maturity is 8% or 10 or 12%? So let us calculate what is the coupon bond, okay? I mean, it's better to use the Excel because that will make the things clear. It will be faster for us to calculate and more clear. So we are asked to calculate 2 bonds, so duration of the coupon bonds if the yield to maturity is 8, 10, and 12%. And you may wish to create a spreadsheet program to assist the calculation. Okay, we can use the spreadsheet, what we are doing now actually. And the part B, it says, how does the change in the yield to maturity affect the duration of this coupon bond? And calculate the duration of the 0 coupon bond with the yield to maturity 8, 10, and 12%. And how does the change yield to maturity affect the duration of the 0 coupon bond? And why does the change in the yield to maturity affect the coupon bond differently than it affects? Okay, let's start with the A part. And so we calculate the duration of the coupon bond for the yield to maturity with 8, 10, and 12%, okay? So let us go with 8%. So what we need to construct, and let us put, first of all, timing, T. And let us put the cash flow, CF, and then we're gonna get discounted cash flow, DCF, and DCF timing the maturity itself, okay? This is what we get it actually. So timing, it's 2 years, it's an annual basis, it's 1 and 2. The cash flows, it's annually, it's like $100 each year. But at the end of the second year, it is the maturity date, which is prepayment back, including the face value as well, which means that is 1,000 of face value plus the cash flow $100, which is promised on that year as well. So we have this cash flow. Okay, and let me just make it bold and make it in the okay. In the middle. Now, discounted cash flow, which means that we need to discount our cash flow with the rate which is given by YTM. It is 8%. So we need to bring it to the year 0, this 100 and 1,100 as well. So this divided by the rate, and the rate is 8%, 1.08. So 92.59. And second one, we do the same thing. This divided by 1.08, but to the power of 2, because from year 2 to the year 0, it will take 2 years. So this is how we discount it. And then, of course, this can be summed. And discount cash flow should be multiplied by the time, which is 92 times 1 period, the maturity. And same thing in here. This times, oops, Yeah, by this. This is what we get it. And of course, we need to get the summation in order to calculate the duration. So summation of this plus this. And the same thing we can apply for this. So this is the result that we were looking for. If we copy it, make it bigger. Let me just increase. Okay, make it. It's better, I guess, I think. And duration is can be calculated as we said that this should be divided by this. This is like simple duration. So that shows that 1.91 years. Okay, like it will require, in order to recover our investment cost, we will need like 1.91 years. This is the duration we calculate. And this is 8%. So it is said, what if it will be 10%? So we just copy it. Okay, I'll paste it here. So I'll put here like 8%. So YTM is equal to 8%. And here YTM is equal to not 8%, but 10%. So what I do, I will just change the discount rate here by 10%, and automatically changes everything, 10%. Okay. This is my, that's why it makes easier to use a spreadsheet and it's faster. Now let us move. Let me make it smaller so that we can see all the spreadsheets. Okay, now, and this is instead of 10%, it's 12%. And I'll change it here to 12. I'll change it here to 12. Okay. So this is this. Now we can answer the question B. Question B. By the way, do you have any question in calculating? This was question A. Sorry, the part A. Now we will move to part B. Part B is not calculation, it's just a logical question. It asks you to give interpretation on the results that you got it. Now, let's move to the B part. So how does the change in the yield to maturity affect the duration of this coupon bond? I mean, just straightforward, we can see the results. Look, as YTM increases, the duration of the bond falls. So we can say that increase in YTM will lead to a reduction in duration. There is inverse relationship between YTM and duration. So this is what we can conclude about B. So let us move further to part C. Now we are asked to calculate with the same rates, but for zero coupon bonds. Same thing, but with zero coupon bonds. So part C. So I'll just copy this. Okay, don't waste the time. I'll copy this and put it here. So with 8%, but zero coupon bond. That means we don't have any coupon payments. So in year one, we will not receive anything. In year two, we will not receive $100 extra. So I will delete this. So I'm deleting this row. We don't need it. Okay. We only need this, and it should be only 1,000. So we'll discount only 1,000. Okay. 1,000 should be discounted by 8%. Okay. And it's gonna be just Okay, and this is going to be only this. Okay, 8%. Now the duration is calculated. If you divide these things, it becomes, and if you make it bigger, okay, it's just 2. And what about this? What do you think? What will be the duration? So it should be 10%, okay, but it is 1,000. And this is this. If you just drag it, same, 2 years, 2 years. And what we have here, so we go to the 12% here, delete, 1,000 here, and this should be okay. There's no problem with that. And we change it to this, same, 2 years. So the duration doesn't change as the interest rate, as the YTM changes. So our duration is remaining same, what we saw here. So what is the question is asked in the following part? How does the change in yield to maturity affect the duration of the zero coupon bond? So the question can be answered. You can just see what happens to your duration. The duration doesn't change. So part D, changes in YTM does not have any effect on duration of zero coupon bond, because the YTM is kind of benchmark that is used to measure the reinvestment in coupon payment. So we don't have any coupon payment. That's why we can see and understand that it doesn't take into consideration, the YTM doesn't affect the zero coupon bond duration. And part E, what is that? Let's see. Why does the change in the YTM affect the coupon bond differently than it affects in zero coupon bond? So increasing in yield to maturity on the coupon bond, that makes for higher reinvestment income. And that, of course, that is making more quickly to recover the initial investment. As I told you at the beginning, guys, that the YTM is related to coupon payment. It's measuring the reinvestment in coupon payment. So the higher the YTM, the higher will be the reinvestment income. So if it's higher the reinvestment income, that will bring more money, and that eventually will cover the cost quickly. And zero coupon bond has no cash flow until its maturity, and in the maturity we receive the face value only. So we are not considering any YTM here. Then the YTM should not affect the coupon bond duration, zero coupon bonds duration, actually. Let me write it. Zero coupon bond has no cash flows, and YTM does not affect duration of zero coupon bonds. YTM is a measure of reinvestment on coupons. and it is directly related to coupon payments. More of YTM will bring more income. Eventually, it will let us to recover investment cost quickly. That's why it increases the duration. It reduces the duration, sorry. Okay, this is the question. Okay.
I have a question.
Yes, please.
Then if YTM doesn't affect zero coupon bond, then why do people still buy them?
It's just
I
to
mean,
receive the face value, like zero coupon bonds are purchased and sold it because they are purchased with a discount. Let's say I'm buying the zero coupon bond for $900, and at the end of the year I will receive $1,000. So I get I get the difference between the discount and the face value amount as an investor.
okay, thank you.
Okay, you're welcome. Now, let us go further. What do we have next? One year of $100,000 loan carries a coupon rate and the market interest rate of 12%, and the loan requires the payment of accrued interest, 1/2 of the principal at the end of the 6th month, and the remaining principal is accrued interest rate due to the end of the year. So, question is, what will be the cash flows at the end of the 6th month and end of the year? Actually, this is question we may just skip it. It's just a question that is easy and we may not spend the time on that. And let's move further to get more complicated questions like what is the duration of the 5 years with the treasury bond? So let's go with this question. This is more interesting question that is more making us to be interested actually. So question 5, what is the duration of the 5-year 1,000 treasury bond with a 10% of semi-annual coupon selling at par and selling with a yield to maturity of 12%, selling at 14%? And what can you conclude about the relationship between the duration and the yield to maturity, and plot the relationship? What does the relationship and why does this relationship exist? Okay, let's go. So we have, it's gonna be semi-annually. So let me just, this is question 1, this is question 3, and this is question 4. Let me just copy one part of it. I'll copy this. I think I made a mistake. It is 5 already than 4. Yeah, it's question 5. Why did I put 4? So thinking about the question 4. Okay, now it is 5 years, but it is traded semi-annually. That means we're gonna put 10 different periods, like 1/2, and which is 0.5 every 6 months, 1, 1.5, 2, 2.5, 3, and so on. We have to put it. For Excel, it's pretty until 5. So we have 10 periods here. Our cash flow is going to be like it's 10% semi-annual coupon 10% semi-annual coupon. The face value is 1,000, that the coupon payment will be $100. Once it's being traded and once it's being paid semi-annually, that means 100 should be divided by 2. Like every 6 months, we're gonna receive $50. In total, annually, we're gonna receive $100. So $50 for each year. So here I go. So 50, 50, 50. And at the end, we're gonna receive 1,000 plus 50. This is what we received, so 150 in total. And now let's discount the cash flow. We know the YTM is 10%. Okay, YTM is 10%. YTM is 10%. This we divide by if you bring it to the year 0, 1.10. And of course, our rate should be changing. If it was 10%, then it should be 1.05. Yes. Do you understand what I'm doing here? Why it's 5% even though we are given YTM 10%? YTM 10%, that means if it's semi-annually, if semi, that means YTM is equal to 10 divided by 2, which is 5%. So our discounted factor is 5%. Now we do the same thing. Let me just drag all here. But in here, it's raised to the power 2. In here, it is raised to the power 1. Make the automatic. Did it work? No, it didn't work because this is 10. This is 9. This is 8. This is 7. This is 6. This is 5. This is 4. This is 3. This is 2. Okay, that makes more sense. If you add them all, let's sum it up. $1,000, and what we do next, we just multiply by the number of the periods, this by this, and we just drag it. Okay, and if you're gonna sum it all, let's sum, and duration is equal to this divided by discounted cash flow years. This is what we've been looking for. This if the YTM is 10%, but what if the YTM becomes 12%? I'll copy this to make our job faster. So YTM becomes 12. If it's 12 and divided by 2, then this becomes 6. Now this 6, I should have connected this. You know what I will do? I will do the following. I will connect this one. I'll make it like this so that the next question it will be easier to follow. This which is 0.06. Fixing it. Okay. This is 2. This is 3. This is 4. I should have done it in a previous example that could save my time actually. This is 5. This is 6. This is 7. This is 8. This is 9. And this is 10. Okay, now my duration is different. Okay, I'll copy this one and try the another way that which will be much quicker. Okay, follow here and put it. This was my interest rate, 6%. Now my interest rate will become how much? I don't remember. Just a second. Let me check the question. If it was 14%, okay, now it's 14. Now if it's 14, that means 14 divided by 2, it should bring you 7. So it's 7%. So in here I'm gonna have 0.07. So that should automatically change my old calculation. Actually, this is gonna 7. Now I will bring yeah. Now what I will do, I will just remove this part. I just change here 7%. Okay, now it's changed. I'm gonna copy this, put it here. Okay, and put this back 6. Okay, now it's 7% here. And I did all the same thing. Now my duration is this one. Okay. So in here, the last question was asked, please construct the relationship or plot the diagram. We don't need to put any, we are not going to plot anything. We just put the duration, okay? Duration, as you can see, what happens? It decreases. So our duration, for, if it was 10%, it was 4.05, then it's 4.01, then it comes to 3.96. So there is a positive relationship between the YTM and the duration that we have solved it, even if it's semi-annually, okay? So as YTM increases semi-annually, that will make duration to fall. This is question 5. Let's go with the question 6, if I'm not mistaken. So consider 3 treasury bonds, each of which has got 10% semi-annual coupon trades at par. So first calculate the duration for bonds that has got maturity 4 years, 3 years, and 2 years. So first 4, 3, 2. So we'll see how it changes. Okay. For simplicity, I'm gonna copy this to make our job easier and quicker. So put paste here. Okay. So the maturity is 4 years. The interest rate is 10%. That means it's 10. That is 5 here. And 5% here we have it. 5% here. So our payments same like 50, 50, 50, but it is 4 years. It should be in total 8 periods. So we don't need this. We don't need this last 2 periods. We're deleting the last 2 periods. And we are left with, this is 1050. Okay. This is what we are left with actually. Now, we need to calculate discounted cash flow. Discounted cash flow is calculated in the following way. I'm gonna put this, wait, okay. What if I do here? I put this one. Okay, now it's solved. Found it out, so I can just take this one up. Okay, that's great. Now we fix it. It's 5. Good. We found it. So our duration, if it's 4 years with the 10%, is equal to 3.39 years. Okay. Now, if duration, the maturity here, the point is here, we're changing the maturity. Okay. The maturity is 4 years. Maturity is 4 years. Then we do the same thing with the maturity with the less. Let's put it here. Sorry. I put it here. Okay. I shouldn't have copied. Okay, I'm gonna do it in this way. So this is, we done it. I'll just delete this. I'll see. Now if the maturity is 4 years here, the maturity in here is 3 years. So if you put it here, what happens? Now we need to change the maturity itself. The rate is the same. That means we have to copy. Yes, sorry for that, guys. That we're gonna reduce the maturity only, so it's just 3 years. we're going to reduce by 1 year and by 2 periods. So in here, we're going to have 1050. So our maturity becomes 2.66 years with 3 years. Then I will copy this. If it's 2 years, our maturity is 2 years. Our maturity is 2 years. And that means that I have to reduce by 1 year, by 2 periods. I'm reducing by 2 periods. And this is 1050. And what you can see, my duration is reduced to even lower number. And what I can see here, what conclusion can you reach about the relationship between duration and the time to maturity? Plot the relationship. Okay. So what we here see that the maturity decreases and duration decreases at decreasing rate. And although the graph can be illustrated, but we're not going to show it here. And what we can draw here as a conclusion that there is a positive relationship between the maturity and duration itself. As the maturity goes down, the duration goes down as well with this decreasing rate. Okay, this is what we can conclude concerning the. So there is no. It's asked to draw a plot to plot the graph, but we're not going to do it. Okay, there is no need for that. We can see by the numbers. Any questions?
It's fine.
Okay, let's go further. It's just straightforward calculations and doesn't require anything. A 6-year 10,000 CD pays 6% interest annually and has 6% yield to maturity. And what is the duration of CD? And what would be the duration of interest were paid semi-annually? And what is the relationship of duration to the relative frequency of interest payment? So now we're trying to test the frequency of payment when it's semi-annually and when it's annually based. So let's do it. 10,000 CD that pays 6% annually and has got 6% of YTM. Just a second. Seven. Now, certificate of deposits, CD with value of 10,000, 6% of annual payment, and 6% of YTM. I'll copy this. Time cash flow. So if it's 10,000, our timing will be annually for 6 years. 1, 2, 3, 4, 5, and 6. And the cash flow is going to be 6% of 10,000, which is 600. 600 here, 600 here, 600 here, 600 here, 10,600. So we're actually, if you understand that we're performing the same thing, 600 divided by 1 plus 0.6. 0.0. 566, okay. That's where we get it. And we will do the same thing for all. I got it. How to do it? This divided by 1.06 to the power of just right. Okay, that will make us to work actually. Yes. Let's see. By 6. Okay. And summation. Okay, 10,000. Convert into dollars. Discounted cash flow. We time this. Now we can see it. Okay. This is, we close it, and duration is equal to this divided by this. 5.21, not dollars, but it's just years. Years. This is what we found it on annual basis, but let's see what's going to happen when it's semi-annually. Does it change or not? So I'll copy this, put it here, but it should be semi-annually, which means that we have to add more of periods. Insert more of periods. That means if it's 0.5, 1, 2, 1.5, and so on, and it should be increasing until 12 periods. Oops, let me make it 4.5 and bring downer. No. This is 5, 5.5. Now I can make it evaporate. Okay. So this is, I have 12 periods. If I just count it, because I need these numbers to raise to the power, 12 periods. Okay, great. And my 600s are same here. So, but it's not 600 in here. It's gonna be 300 because it's a semi-annually. 300. Okay, and in here we're gonna have 1,300. And our interest rate is, rather than being 6%, it's gonna be 3%, the YTM, because 6 divided by T, okay, because it's a semi-annually, and we change this one.
I'm sorry, it shouldn't be 10,300.
Very true. Thank you so much that you're following me. Thank you so much. That's very true. I'm still getting the number semi-annually. Okay. And that should be 10,300 instead of 1,300. That's good. Thank you so much. That means that you're really following me. Now, we have 10,300 in here, and the rate, we're going to include 3%, and we will raise it to the power of 1. We're going to raise it to the power of 1. Okay? And if we raise it, here we go. Just a second. So did I perform correctly or not? Let me just check it. 10,000, this, okay. This is okay. And this. I'll make it bigger so that I can see more clear picture of what happening to the duration. Okay. Now, so we found it like if it was annual and semi-annual. So we can conclude that duration going down as the frequency of the payment increases. That means if you make it quarterly, that will reduce more. So there is an inverse relationship between frequency of payments and duration itself, okay? This is what you have to conclude in here. So as the frequency of payment increases, the duration falls. It was 5.21, now it becomes 5.12. So let me save this one so that we may have, I will upload it as well. Example, questions, solution, chapter 9. Do you have any questions? These calculations are straightforward. Tomorrow we will go to more complicated questions that may require even further explanation and more dealing with this. So this is a thing that you need to understand how to calculate the duration, the simple one, but we'll move to duration gap and changing networks and changing interest and so on. If you don't have any questions, and thank you for your attendance. See you tomorrow.
Thank you. Bye.
Bye.
Thank you. Bye.
Bye.
Goodbye.